All right, so now we're working with example 3, and it's powers of tangent, and we're trying to find the tangent to the fourth of x dx. The reduction formula for tangent says the integral of tangent to the n of x dx when n is even, or when n is positive, excuse me, turns out to be tangent to the 1 less power of x over n minus 1 minus the integral tangent to the n minus 2 power of x dx. So that means that this is going to turn into 1, we're dropping the power by 1, so it'll be a 3, so 1/3 tangent to the third of x minus the integral of, drop it by 2, tangent squared of x. Oh, but now we have to use the rule again, so we have the 1/3 tangent to the third of x minus, in parentheses, the rule says drop it by 1, so tangent of x to the first power and a 1 minus the integral of tangent 0 of x dx, which this is the same as 1. So I end up with 1/3 tangent cubed of x minus tangent of x. And then I have minus a minus. The integral of 1 is just x, so plus x plus c. All right, so now we're going to go on to the next example. Before that, remember, this problem still could have been done by using another trig identity and substituted it in and then used a u substitution. So that would have worked as well. Then we have integrals of tangent, cotangent, secant, and cosecant listed in your book. And there are some proofs for it for you, but I'm not real concerned with these higher ones without having the rules in front of you because you're not going to be able to remember them. So we have the integral tangent cubed of x secant to the fourth of x dx. And it says, evaluate it. Okay, we've got an even power of secant. So we know the derivative of the tangent is the secant squared. So I'm thinking make it a secant squared of x and another secant squared of x dx. Use this guy for your derivative. Change this one using that trig identity I just wrote up there in example 3. So this would turn into tangent cubed of x, and then the secant squared would be equal to the tangent squared plus 1. And we don't need to multiply this whole thing out. We can do our u substitution right here. The u is going to be the tangent of x, so the du is going to be the secant squared of x dx. So this turns into u cubed u squared plus 1 du. At that point, I'd be inclined to distribute that and make it u to the fifth plus u cubed du. And now when I raise the power and flip it in front, and now put back what the tangent is equal to the u, so 1/6 tangent to the sixth of x plus 1/4 tangent to the fourth of x plus c. And that was part A. So let's get part B. This time we have tangent squared of x secant of x dx. Okay, so this one's going to take a little more work. And I'm looking in the book, and again, you could have done 4A differently. You could have taken off a tangent and you kept a secant tangent for your du and done it that way and used all secants in your problem. If you did that, let me go back up here, I would have rewritten this as tangent squared of x tangent of x, and then that secant to the fourth, I would have made it as a secant cubed, or secant of x and a secant cubed of x. I would have used these for my du, and that's derivative is the derivative of the secant. It's the secant tangent. So then I would change this to secant squared of x minus 1 and do all my u's as secant of x and my du's as the secant tangent. And that would get me the same. It would still work out, but the result would look totally different. It would say 1/6 secant to the 6th of x minus 1/4 secant to the 4th of x plus c. Now they look different, but if you use the identity 1 plus tangent squared of x equals secant squared of x, they will be the same thing. So there are two ways of doing that one. This is the second way. I'll mark it number 2, and then this would be my number 2 answer. All right. This last one. I'm looking at this and I'm thinking I'm going to have to change the tangent. I'm going to change it to a secant squared minus 1. And we have times secant of x dx. I'm going to distribute that and split it into two separate problems. Now, the secant cubed uses the reduction formula in your book number 4. That rule says, I'm going to write it down for you. It says secant to the n of x dx, the integral of that, turns into secant, drop the power by 2, x, tan of x over n minus 1, and then plus n minus 2 over n minus 1 integral secant dropped by 2 of x dx. And n cannot be 1 because it puts us backwards. So if I use that reduction formula on my secant cubed, it would turn into secant, putting in 3, so secant 3 minus 2 is 1. So secant of x, tangent of x over 3 minus 1 is 2, so a 1/2 in front, plus 3 minus 2 is 1, 3 minus 1 is 2, integral of secant cubed dropped by 2 is secant of x dx. Is that right? And then I still had that minus integral of secant of x that came from right there. Putting those two integrals together, I have a positive 1/2 and a negative 1, so I get negative 1/2, the integral of the secant of x dx. And so I have 1/2 secant of x, tangent of x, not plus, minus 1/2, and the integral of the secant is the natural log of the secant of x plus the tangent of x, and then plus your c. Really, really ugly ones. All right, that concludes a